So we're going to do expected value, and there's probability and payback. All right. So let's look at this. We've got some gambling going on. So we've got 500,000 people that pay $5 each to play a game, and these are the number of prizes. So let's look at the number of winners. How many winners do I get, right? So I have one big one, 10 second prizes, 1,000 third prizes, and 10,000 fourth prizes. So what does that give me? 11,011, right? That's the number of winners. So how many losers do I have then? So that's 500,000, subtract off, oops, sorry, got really messy. Okay, so how many losers are there? 488,989. Okay, well, look at all those losers. All right, so let's look at what the expected value would be. So the expected value would be the probability times the payoff, right? So I'm going to do the probabilities are all the same, right? So the probabilities are all the same of 1 over 500,000. Okay, so now I'm going to add up the winners and how much they win, what the possible outcomes would be. So there's one winner who wins the $1 million, right? So that's going to be the $1 million. Oh, but that person had to pay $5. So that's the one winner. So this is what I'm calling the A, the payoff, and then this is multiplied times the probability. So that's this term right here. Okay, plus. Now I've got the probability, still 1 over 5,000. Now I've got 10 people who are going to earn or win $1,000. Oh, but they had to pay $5, right? So these are the $10, right? This is the $10 second place winners. Okay, add on. So then the third place winners, that's right, so there's 10, sorry, not $10 there. 10 of the 10, that's number of the 10, and then the second place winners get the $1,000. Sorry, I got that mixed up. Okay, so now I have 1,000 third prize winners, so this is the number of them, and the third prizes are $500. So 500 minus the $5 that they purchased the ticket for, plus. Now there's 10,000 people who are fourth place winners, and they get $10. So that's $10. Oh, but they had to buy the ticket for $5, right? Okay. Then I need to count the rest of the people who lost money, because the rest of the people, so let me just come down here, right? The rest of the people lost, so how they, the 488,989, they lost $5, right? Because they didn't win anything and they spent $5. Okay, so if I add all of these numbers up, do you know what I get? It does not pay to gamble. How about that? Okay. All right, here we go with looking at numbers of choices for expected value. So I've got an urn, which is just a big container that contains 4 balls, and these are the numbers on the balls. Okay, so a person selects 2 balls at random. So what's the expected value of the sum of the numbers on the balls? Okay, so for the 2 3s, I'm going to call one 3-1 and one of them 3-2, right? Because they're different ones, even though they've got the same label. All right, so what I want to do is I want to look at what the different possible combinations are. So I've got the 2 3s I could pick up, one of the 3s and a 7, and the other one of the 3s and the 7. And so then what can I do? I get one of the 3s and the 8, and the other one of the 3s and the 8, and then just the 7 and the 8, right? Okay. So then I have what the sum of the balls would be. So here I would get 6, here I would get 10, here's 11, and here's 15, right? So what's the probability of getting this, the 2 3? So it would be 1 out of, so let's look at how many choices I have here. 1, 2, 3, 4, 5, 6. So 1 out of the 6 choices gives me the 2 3s. 2 out of the 6 choices gives me the 3s and the 7s. 2 out of the 6 choices gives me the 3s and the 8s. And then 1 out of the 6 choices gives me the 7 and the 8. So what is the expected value? So it's going to be the sum of 6 times the probability of 1/6, the sum of 10 times the probability of 2/6, the sum of 11, 2/6, and the sum of 15 times 1/6. All right, I'm going to let you do this one.